Joe Trabulski, VP of Sales and Marketing here at Hitachi Comarch. Today's video is the 8th in our short-form series, providing you with product introductions and overviews. Today I'm here to talk to you about the QoS-1000 RF Monitoring Receiver family available through Hitachi Comarch and Comarch Digital Services, CDS. Before we get into the specific product demo, I thought I would provide a bit of background info on CDS. Originally formed back in 1997 during the transition from analog to DTV, the mission of CDS was to help customers implement turnkey encoding systems at a time when customers didn't understand technologies such as MPEG, PSIP, and transport stream management. In 2018, we relaunched CDS as our in-house integration, test, and deployment group, and they have already helped several broadcasters with end-to-end next-gen TV solutions by offering customers a team of experienced broadcast professionals that understand the complex world of both IT and encoding. The QoS-1000 RF Monitoring Receiver, manufactured by Avateq Corp., is a device that allows engineers to cost-effectively monitor their digital transmitter system's performance. It's available as either a 1RU rack-mounted unit or a portable receiver, with each supporting ATSC 1.0 with an option to upgrade to ATSC 3.0. Using high-precision demodulation and signal processing, the QoS-1000 analyzes the RF signal and provides near real-time user metrics, including symbol and constellation diagrams, as well as RF spectrum, RF shoulders, MER/SNR, and frequency response or group delay. The QoS-1000 has a built-in web server that hosts a user-friendly GUI that provides a window into the heart of your RF signal. Now that I've introduced the QoS-1000, let's head to the lab for a demo. So here we are in the CDS lab where we have our QoS-1000 mounted in the rack, receiving a signal. This is the user GUI interface for the QoS-1000. Starting on the upper right-hand side, you can see this one has the optional ATSC 3.0 standard enabled. It tells you your channel number, your channel frequency, which RF input port you're using on the device, and the input power level. Over on the left-hand side, you can see the MER of the signal and your right and left shoulder, as well as carrier frequency offset. You can go into settings and name your unit. This unit's been named CS Lab, Site ID Southwick, Massachusetts. And over here we have a variety of different icons to get into the different items that we're monitoring. In the main part of the screen, you can see we have the spectrum display of the 6 MHz channel. You can click on Statistics, brings up this window where you can scroll through and look at all the different information in your signal. Obviously this unit's enabled in ATSC 3.0, so this icon brings up the ATSC 3 signaling, including the bootstrap information, shows the L1B signaling information, and the L1D signaling information. The next icon is the LLS table. This shows your SLT, your service list table, and the STT, the system timetable. This icon brings up the CCDF of the signal, showing your peak to average. This icon brings up the echo profile. This icon shows the channel response. So you have both amplitude response in yellow and phase response in this bluish purple color. Next item shows the group delay response of the channel. Here you can look at SFN drift. And again, we have ATSC 3, so this is showing the constellation of your system. If you're running LDM, here you can see both the core and the enhanced layer. We're not running LDM in this demo. This icon allows you to look at the bootstrap constellation. And then the next two constellations are the L1B constellation, QPSK, and the L1D constellation, also QPSK. On the bottom, you have a couple additional icons. This one is the control panel. Control panel looks like this. You have a global status showing a lot of the information we just went through. This is also where you do your configuration of your settings. So this tells you to use the unit and run which RF input. This one's RF input 1, what frequency, the channel mode, if you have an equalizer on and off, spectral. The Alarms tab allows you to go in and set up the alarm properties. Allows you to go in and set your thresholds. So this is all user configurable. The unit can email you in the event of an alarm. Here's where you go in and set up that information. SNMP is set up through here. And then on the Systems tab, we have site information, access settings, network, etc. So again, here's where I went in and named it CES Lab in Southwick, Massachusetts. Network IP addresses, etc. Last icon is this one. This allows you to print a report, snapshot of what's happening with the signal coming into the Avateq, the QoS-1000. So again, this shows the site ID, site name, date and time stamp, standard, frequency, and then all of the different statistics and parameters that are currently monitored as of the time the report was generated, including all the diagrams. This report can be saved for archival use. So that's it. Very easy to use, simple to set up, and powerful in terms of its capabilities for monitoring your RF signal. So, in summary, the QoS-1000 test and measurement tool is perfect for RF signal metrics and monitoring of ATSC 1.0 or 3.0, provides you with an easy-to-use and powerful web GUI, includes an event and alarm log with user-defined parameters and threshold, and uses the latest second-generation platform that provides faster screen refresh rates of under 1 second. For more information or a quote, simply contact us at sales@comarktv.com. That's sales@comarktv.com. Think Hitachi Comark and CDS for all your RF test equipment, ATSC encoding, and next-gen TV needs. And look to Comark Digital Services for all things ATSC 1.0 and 3.0. CDS will bring your project from strategic vision to on-air reality. Thanks for watching.